Hello viewers, today we are coming with another class of engineering drawing. Today's topic is projection of line in first quadrant. Okay, we have discussed the quadrant system in previous lectures. If you have not seen those lectures, you can see. I will give the link of those videos in the description box. You can see those also. So today's topic is projection of line in first quadrant. Okay, now we will go simply with a question. We have written this question here, question number 1. Okay, what does question say? I will read the question. A line PQ of length 60 mm, okay, whose end P is in HP and Q is 30 mm in front of VP. Okay, this is the condition of the 2 points. Further, it says the line is parallel to VP vertical plane and making an angle of 30 degree with horizontal plane. These are the given conditions of the line PQ. What we have to do, we have to draw its projections, okay, that is front view and top view in first quadrant. In first quadrant, we have to draw its projections, that is front view and its top view in first quadrant. I have already drawn here. I will explain how you can proceed. Okay, first of all, we will see what is given to us. We have a length of the line, that is PQ, 60 mm long. Okay, that is 66 centimeter. P is in horizontal plane, HP is in horizontal plane. Okay, second condition, Q 30 mm in front of VP. Q point is in 30 mm in front of VP. Line is parallel to VP, means when line is parallel to VP means P is also 30 mm in front of vertical plane. Okay, angle is given to us. Angle which the line makes with horizontal plane is 30 degree. That is denoted usually by theta. Okay, now what you have to do, simply draw the XY line. This is the final view which you will get. You know that in the first quadrant we have this XY line which separates the two planes. Above XY line we have VP and below we have horizontal plane. This is the first quadrant system. Okay, and you also know that angle of the line which it makes with horizontal plane will be visible to us in front view. Okay, in front view, and its true length will be also visible to us in front view. We will start with front view. Let us demonstrate it with the help of this model. Let us say this is the line PQ. Okay, what are the conditions of the line? P lies in HP or is in HP, P point. It is like this. Okay, this point we don't know is where it is it like this, like that, but we know that in the question it says line is parallel to vertical plane, means it is also 30 mm in front of VP. That's why by that only it can be parallel to the vertical plane. Okay, so it is not like this, it is not like this. Okay, it is like this, it is parallel to vertical plane and inclined to horizontal plane. This is an inclination. Okay, now when we see from the top view, we will not be able to see its angle, nor will we be able to see its true length. So we have to start with the front view like this. Okay, when we see from here, okay, PQ will be visible to us in original length 60 centimeter. Okay, 60 mm, sorry, that is 6 centimeter, and this angle will be visible to us in front view. And you know that front view always is drawn on vertical plane. Okay, when we project this line, this projections, this line, the projections of the line will be on VP. This will become its front view. Okay, so we will not be able to see its distance, how much it is away from VP. We will be able to only see, imagine like this, we will be able to see its length and angle, but its projections means if we put light from here, its shadow will fall on VP. That's its front view. Okay, let us draw first of all its front view. Front view will start from this XY line. This is its P dash, and at an angle of 30°, we will incline a line that will be the true length of the line, that is 60 mm long. This is Q dash. Okay, you have to represent the front view with small letters and dash on it, P dash, Q dash. Okay, PQ is the line, but this is the true length. True length of the line PQ. Okay, that will be visible to us, and this is the true angle. True angle of the line which it makes with horizontal plane. Okay, then you have to draw two projectors from P dash and Q dash. Those projectors should be very thin. Okay, up to this point. Then we will go back to this model. Okay, line is like this. This is P and this is Q. When we see from the top, and you know that top view is always drawn on the horizontal plane. This is horizontal plane, this is vertical plane in two-dimensional view. This is the 3D model. Okay, when we draw the light from the top, its shadow will be like this. Okay, projector is like this, means it will come on this point. Okay, we are not supposed to rotate it like this. It goes out from this horizontal plane, means it is true length. But in case of top view, we will not be able to see its true length. We will be able to see its apparent length. This is its projector. Okay, it will lie on this point, and this is the point. And how much we have to go away from this vertical plane, that is given to us, that is 30 mm. Okay, this is 30 mm, this is 30 mm. Okay, means from this point we have to go 30 mm. This is P, small p, and from this point we have to go 30 mm, that is Q, and we have to simply join this line like this. This is its top view, and this is its front view. Okay, but this length is not true, it is apparent. Apparent length of line PQ. Okay, got it? How much is this distance? This is 30 mm. This is also 30 mm. Okay, this is also 30 mm. This is also 30 mm, and this P and Q is top view, and this is front view. So in this question we have understood that the angle, true angle, is visible to us in front view when the line is inclined to horizontal plane, and true, this is angle, okay, and true length is visible to us in front view itself, okay, in case of the line when it is inclined to horizontal plane. Okay, we will add when we say it is parallel to vertical plane. This is vertical plane. You can see this line is parallel to this XY line. This means that the line is parallel to vertical plane but inclined to horizontal plane. The inclination theta is visible to us in front view, and the parallel condition of the line is visible to us in top view. Okay, I think you have got the point. This is a very simple question of the line which is parallel to vertical plane and inclined to horizontal plane. Okay, thank you for watching.